everyone, we're going to talk about differentiability of functions, and we're also going to get into graphing the derivatives of functions. So we're going to start with this famous function, the absolute value function. And the question is, where is this function differentiable? More so, where is this function not differentiable? And when this function is differentiable everywhere except for one location, at x equal to 0. Why? Because differentiability, derivatives deal with slope. Everyone, what's the slope of this line right here? Coming in as you approach x equal to 0 from the left. The slope is -1. F prime is -1. What's the slope of this line as you approach 0 from the right side? The slope is 1, or f prime equals 1. These slopes, everyone, are not the same. Therefore, this function is not differentiable at x equal to 0. That's a corner. So now I want to talk about, well, how about all functions? Where are all functions not differentiable? One place is when functions have corners. Okay, just like this one in the absolute value function. I'm going to draw a picture of one. Here we go. Let me just say, all right, this function has like a cusp here, maybe comes down here, has a discontinuity there, maybe gets really vertical here, and then it goes on like this. And I'll just make up some x values. Let's say this is at x equal to -3, and when this is at x equal to 3, and perhaps over here when this is at x equal to 7. First of all, the question is, where is this function not differentiable? All right, where is the function not differentiable? To start with, this is called a cusp, kind of like the corner. Everyone, this slope coming from the left side is getting really steep. Look, it's almost getting undefined here, but these slopes are not matching as you approach from left and right. This function is not differentiable at what's called a corner or cusp. So definitely not at x equal to -3. That's one place where this function is not differentiable. At x equal to 3, we have what's called a jump discontinuity. All right? A jump discontinuity. See, everyone, if a function is differentiable, then it's continuous at that point. Function's differentiable at a point, it's continuous at that point. But you can't take the converse of that statement. All right? What I mean is, you can't say, oh, a function's continuous, then it's differentiable. If a function's not continuous at a point, it's not differentiable. And therefore, at x equal to 3, when you have what's called a jump discontinuity. So when I'm going to put that right here, at x equal to 3, this function is not differentiable. At x equal to -3, it's not differentiable. And lastly, at x equal to 7, everyone, there's a vertical tangent there. All right? So whenever you have vertical tangents, that means, everyone, the slope right here is just undefined if we put a tangent line right there. So the three places I want you to always think about where functions are not differentiable are at J's, V's, and C's. Jump discontinuities, vertical tangents, and corners or cusps. Okay? So in this problem, just to wrap it up, this function was not differentiable at x equal to -3, at x equal to 3, and x equal to 7. Now, I'm going to erase all this, and I'm going to talk about graphing a function's derivative. So I'm just going to start with this function right here. Whoop, whoop, whoop. Everyone, if you know your trig, this function may look very familiar to you. We'll just call this f. What we're going to do is graph f prime, its derivative. Everyone, this is simple to do. It's very simple. What we're going to do is, first thing, I want you to find where the slope of this function is 0. Ah, right here, we see that the slope is 0. Right here, the slope is 0. Everyone, right here, the slope is 0. It's good to identify that right away. That means, everyone, f prime is 0 here. F prime is 0 here, and f prime is 0 here. Watch how we make this graph. I'm going to put a point right there. Because the slope, everyone, f prime, derivative, is slope of f. The slope is 0. So I'm putting a point there. Aha! Putting a dot there, and look. Putting a dot right there. Slope is 0 at this point. Slope is 0 at this x value. Slope is 0 at this x value. Now, how about the rest of this curve? Well, let's just go in here and look and see if the slope is positive or negative. How about right here, one? That slope, we can definitely see it's negative. I don't know, like a -1. Do you all agree on it's about a -1? How about right here if I drew a tangent line? Slope is definitely positive. Probably like a positive 1. How about right here? Notice I'm going in between these values here. The slope right here, once again, it's negative. See how this slope is negative? F prime is negative. So I'm just going to put a value here in the negative region. And how about like right here? The slope, everyone, right there would be positive. Now I can build this graph. And when I have a nice woo, 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 and I want, now I can make sure this is lined up here. If you know your trigonometry, that sine, you might realize that this is actually something like the cosine curve. So if you haven't gotten a trig yet, you know the derivative of y equals sine x is cosine of x. So anyways, let's do another one. I'm just going to take y equals x cubed. There we go. Let's do this again. I want us to graph the derivative. All right, where's the slope 0? Right here. Everyone, tangent line, m equals 0. Boom! What's the slope right here? It's positive. Okay. How about over here? Hey, it's positive. Hey, you know what's interesting about this graph? The derivative is always positive. This is f prime. The derivative is always positive. Yeah, this function's always increasing. Now, if we want to get a better concept here, we can dive in here and say, what's the slope here? Well, it's positive, but it's very close to 0. But way out here, boy, it's really steep. So we see how this thing is just getting really steep. And right here, when this slope keeps getting very, very steep, that would give a large value for f prime. And when you might notice this is a parabola. And yes, the derivative of x cubed is 3x squared, which this is demonstrating. And one last thing. Let's go back to the absolute value function. Let's graph that derivative. Okay. Here's the absolute value function. Psst, psst. And how do we do this? Well, yeah, the slope's negative. The slope's positive, but the slope is 0 nowhere. The slope is 0 nowhere. We didn't have those nice little hills. How those previous graphs were nice and smooth. If you notice about this line, everyone, what's the slope right here? Slope is -1. What's the slope right here? The slope is -1. What's the slope right here? The slope is -1. The slope is always -1. So what this graph would be? This is just the slope that's always -1. And how about this? Oh, the slope is 1 here, the slope is 1 here, the slope is 1 here. This slope's always going to be a 1. Now what should I put here? Should I put dots? Should I put a dot at one place or the other? No. Everyone, we're going to open these up. How come? Because this function is not differentiable at x equal to 0. This is f prime, this is f. That's why we're not making a mark there.